Hey Falcons, we're going to talk a little bit today about real world patterns and when are we going to apply this knowledge about using input and output tables. Okay, so let's think about what we already know about input-output tables. We know that every table has a rule, and that rule is going to show us the relationship between the input and output. Okay, those numbers, if they are getting bigger to go from going in to out, we know that they're either multiplying or adding, and if they're getting smaller going through that table, we know that they're going to have a subtraction or division to make them smaller. Then we know that that rule is written as an equation. Okay, so where are some places that you might use this? We know that tables help us see patterns. There's patterns everywhere. We know that there's patterns in science and in nature. Well, we also know that there's patterns in math. We can see patterns with shapes. If you're ever building something or drawing something, we can even see patterns there. And whenever we're making recipes and purchasing goods, we're going to go into a little bit more detail of what do I mean? How is there a pattern in some of those things if we want to resize or create something? Okay, let's take a closer look at that. Okay, here's an example of shapes. We can see that if a shape has three sides, we could see the relationship between sides and vertices is a one-to-one correspondence, meaning that that rule would be multiplying times 1. Number of sides equals the number of vertices. Okay, let's take this a little step further. Okay, what if we were drawing or creating our dream home? And we need to know all kinds of things about creating this home. We need to know how much materials we need, how big is it going to be, all kinds of different things. So I have this an input-output table, and I have the drawing of my dream home. Well, I don't want my dream home this small, so I'm going to use a scale that helps me know that my drawing for each inch is going to represent a certain number of feet. But as you can see, I'm not sure for 1 inch how many feet are represented by that 1 inch. Well, if I look at my table, I might see a pattern. I'm going to need at least 2 full sets to notice this pattern. I see from my input of 2 that my output of 6 is getting bigger. That means it's either addition or multiplication. 2 and 6. That sounds like a fact family, I know. Let's look at another complete set. We have the inches, 7. It goes in 7, and it came out 21. Light bulb. This is a fact family of 3. So you might have figured out, oh my gosh, this is my rule. So figuring out what goes in the feet in this first box is going to be easy. That's going to be 1 times 3 is 3. This one's easy too. 4 times 3 is 12. And then we get to here. What are we going to do when we have to work backwards? We don't have our input. We only have our output. So you have to think about this as we know that our rule is times 3. Something times 3 has to equal 18. So you're really working backwards here. You're almost thinking about a division problem when you work backwards. What is 18 divided by 3? And then you'll know, you can do still a little bit of math, or you might know this fact off the top of your head. That's going to be 6. So now I can see that my rule, my equation is 6 times 3 equals 18. So I know that that would have been 6 inches. So if I measured my drawing over here and measured out 6 inches, I know that that maybe my kitchen is going to be 18 feet long. So that's just a few ways that you might see an input-output table used in a real-world situation. Now, there's so many more. I'm sure you could think of some on your own. Maybe you're doubling a recipe. But now it's your turn to try. So you could think about doubling a recipe, all kinds of ideas. I know we have some work posted online for you guys, and I'm excited to see you give it a try.